Welcome back to Saxon Math. This is lesson 44, simplifying decimal numbers and comparing decimal numbers. It's a new concept. Perform these two subtractions with a calculator. Which calculator answer differs from the printed answers below? So let's just go ahead and use the calculator for a second here. So when doing 425 minus 125, you get 300. When you do 4 and 25 hundredths minus 1 and 25 hundredths, you get 3. All right, calculators automatically simplified decimal numbers with zeros at the end by removing the extra zeros. So you didn't see these digits on the calculator. Many calculators show a decimal point at the end of a whole number, although we usually remove the decimal point when we write the whole number. So 3.00 simplifies to 3 on a calculator. We remove the decimal point and write 3 only. So example 1, multiply 25 hundredths by 4 hundredths. So in this case, we have 25 hundredths and we have 4 hundredths. And if we're multiplying these, we just multiply them as if they aren't decimals. So for just a brief moment, just ignore all these and all those decimals, and you end up with 25 times 4. Everybody knows what 25 times 4 is because you know quarters. It's 100. So in this case, now we have to count the decimal places. There's 1, 2, 3, 4. So we have to move over to the left. 1, 2, 3, 4. We have to have a 0 in this place, and then a decimal here, and another 0. Now this one is simplifying decimal numbers, means we get rid of those zeros. We don't need them anymore. So that equals 100th. So when you multiply, you perform this on a calculator, it's going to have just this displayed. The calculator simplifies the answer by removing the zeros at the end of the decimal number. So 100, this would be tenths, hundredths, thousandths, 10,000ths. This would be 110,000ths. That's the 10,000ths place with the TH. 10,000ths with the THS. Simplifies to 100th. In the book, decimal answers are printed in simplified form unless otherwise stated. Comparing decimal numbers. 0 at the end of a decimal number does not affect the value of the decimal number. Each of these decimal numbers has the same value because the 3 is in the 10th place. So this is 3/10. This is, we would read it 300ths, but it has the same amount, same value as 3/10 because we can just get rid of that. And this would be 300,000ths, but we simplify it to 3/10 because we can get rid of those. Although 3/10 is the simplified form, sometimes it's useful to attach extra zeros to a decimal number. For instance, comparing decimal numbers can be easier if the numbers being compared have the same number of decimal places. So if we were to say, oh, for example, if we're going to say what's bigger, 25 hundredths or 300 thousandths, or is 30 hundredths, or is 3/10, which one is bigger? Well, if you're going to compare those, you might say, well, let's look at this. This would be 30 hundredths and 25 hundredths. And you can see clearly that 25 hundredths is less than 30 hundredths, which means 25 hundredths is less than 3/10. All right, let's look at another example. So comparing 3/10 and 303 thousandths. So using that mindset, we might want to rewrite 3 as 300 thousandths. And then if we look at the other number, 303 thousandths, well, right off the bat, you hopefully can see that 303 is a bigger number than 300. So therefore, in this case, 3/10 is less than 303 thousandths. When comparing decimal numbers, it's important to pay close attention to the place values. Writing both numbers with the same number of decimal places can make comparing easier. We will attach 2 zeros to 3/10, so it has the same number of decimal places as 303 thousandths. And then you can notice that it's 300 compared to 303, basically. 300 thousandths is less than 303 thousandths, so we would write your answer as 3/10 is less than 303 thousandths. Example 3, arrange these numbers in order from least to greatest. So again, because I'm comparing decimals, I want to make sure I have the same number of decimal places in all of those. And now I'm looking at it like this. This is like 300, this is just 42, this is 240, this is 235. Hopefully you know the difference between those values if they were whole numbers. So now that they're written out in this manner where you have the same place value, the thousandths place, you can see clearly that 42 hundredths would be the smallest. So 42 hundredths, then it goes to, looks like 235 thousandths. Sorry, that was 42 thousandths. Then it's 235 thousandths, and then I have 240 thousandths, which is the same as 24 hundredths. And this one would be the last one because it's 300, but the original form that they wrote it in was 3/10. We write each number with 3 decimal places just as I did up there, and then you can arrange those numbers in order, omitting the ending zeros. So just keep in mind it'd be like 42. It goes in that order: 235, 240, and then 300, and then you just get rid of the zeros that you added on, and it's back to the original format that it came out in. All right, let's try these. So write these numbers in simplified form. Letter A, go. Simplified form of this one would be 5 hundredths. Letter B, go. Simplified form of that would be 50. Letter C, go. Simplified form would be 1 25 hundredths. If you didn't recognize already, we're just taking off these zeros, simplifying them. It's an equivalent value. It's the same exact value. So that's what they're talking about. Write these numbers in simplified form. You don't need those zeros, don't need these zeros, don't need this zero. It's the same. See that? So you're simplifying. So letter D, go. Should have been 4. And comparing 2/10 and 15 hundredths. If you put this as 20 hundredths and 15 hundredths, you can see that 20 hundredths is bigger, so 2/10 is greater than 15 hundredths. This one, you don't have to add any zeros to this, but you can see clearly that 12 is larger than 1. 12 is greater than 1. They're the same numbers, but they're different values because the place values is different. Letter G, 12 thousandths and 12 hundredths. All right, to figure this one out, you should have added a 0 on there to make it equivalent place values compared. And notice this is merely 12 and this is 120. Therefore, 12 thousandths is less than 12 hundredths, which is what the original problem was. Letter H, 31 hundredths and 39 thousandths. All right, this one you can see it's 310 and this is 39, so therefore 31 hundredths, which is what the original answer problem was, is greater than 39 thousandths. I bet some of you were fooled because you said, oh, this is 39, oh, this is 31. No, don't look at that. You have to add that 0 to make sure it's comparing the same place values. Letter I, 4/10 and 40/100. All right, if you noticed, these are equal because if you add a 0 onto this one, it becomes exactly the same as that one. Letter J, write these numbers in order from least to greatest. All right, to do this one, you're going to want to make sure you have the same place values on each of those. So 120, 125, 15, and 200 is what you're thinking about. So I'm going to say this is the first, 15 thousandths is the smallest. Then I see that 120 is this next one, but I want to do the original problem that they had. So 12/100 is next. And then 125 would come after 120, but I need to do the original problem. And then I see this one would be, the original is 2/10, so that looks like this. We added the 2 zeros to make it 200 thousandths. We had to go to the thousandths place because these were at the thousandths place. So we had to add a 0 here, we had to add 2 zeros there. This would have been your final answer from least to greatest. All right, excellent work today. Make sure you complete your written practice during class. We'll see you tomorrow.